Before switching on the system to run your magnetic nanoparticle samples, make sure everything is connected properly once again. Especially make sure that the water inlet and outlet is okay, as the coil enclosure will not switch on if they are not connected properly, or if the water inlet pressure is below or too far above 320 milliliters per minute. After that, look into the reference matrix sheet for your magneTherm system. This will show the exact combination of coil, capacitor box, power supply and function generator settings to achieve the required AC magnetic field. This sheet is unique for every system and is provided by nanoTherics for each system. If you want to test your sample at 110 kHz with 25 millitesla, switch on the function generator first and input 110 kHz. Make sure the current is set to its maximum and the voltage is set to its minimum in the DC power supply. Now switch on the DC power supply, coil enclosure and the oscilloscope. Take 1/3 of the voltage input for 110 kHz from the matrix sheet, 10 volts. Now slowly increase the voltage to 10 volts and you will observe a peak-to-peak voltage increase in the oscilloscope signal. Now tune the circuit to its resonant frequency, i.e. the frequency at which the current is highest within the circuit. When this tuning is done, lower the voltage back to 0. Now take the sample, make sure it is in contact with the temperature probe, in this case a single channel optical probe interface, which monitors real-time temperature variation within the sample. Place the test sample within the polystyrene sample holder. This is designed to prevent non-specific heating. The cooling water circulating within the coil and the polycarbonate wall separating the coil from the sample holder also serve this critical purpose. Increase the voltage slowly to its maximum to achieve the peak-to-peak voltage provided in the matrix sheet. Now you will be able to observe and record the real-time temperature change within the test sample. The power loss calculation program will provide the specific absorption rate, specific loss power, intrinsic loss power values for the test sample and facilitate the user access to the raw data in Excel format for further interpretation. The calibration liquid, i.e. 20 mg per mil concentration of 50 nanometer size magamite provided with the system will show an increase in temperature over time, allowing the user to view magnetic nanoparticle heating in an AC magnetic field. Example sample data. Rate of change of temperature over time in citrate stabilized 11 nanometer size magnetite suspended in water exposed to different AC magnetic fields. Heating property of magamite aqueous suspension implant in mouse, in vivo data. Real-time temperature change comparison between continuous and pulsed AC magnetic field in DMSA stabilized 15 nanometer sized magnetite suspended in water.